Will. Phones away. Thank you. I think as I'm going to say, probably again, like last term, if I see you guys using your phones in my class, I'm immediately taking, there's no more warnings. Yeah, every single session I come in, I'm just calling out the same people, phone after phone after phone. It doesn't make sense. You come into class, you get ready for class. Your phone, you could leave it for 50 minutes. It's absolutely fine. We're not glued to our phones. All right, here we go, exercise 13B. I want to go through your index laws again. So if we want to evaluate is different to simplifying. Simplifying, for example, would be a to the power of 3 multiplied to a to the power of 4. We don't want to write two terms. Instead, we write it together as a to the power of 3 plus 4, which simplifies down to a to the power of 7. That's called simplifying. Evaluating means that I want to know the value. I want to know what it equals to. So, how do I do negative 64 to the power of a third? Your goal is to simplify the problem first before you could evaluate it. If you know the answer straight away in your head, then you can write down the answer. But I'm showing you a technique to solve this problem. 64. You want something because you notice the third, power of third actually just means third root. So cube root of something gives you 64. Or 64, cube root of 64. So something times itself 3 times gives you 64. Now that's where you have to go through your times tables. What will multiply itself 3 times, multiply itself 3 times to get 64? What number would that have to be? What number would that be? So if I gave you 2 times 2 times 2, so that gives you 8. So cube root of 8 is 2. Cube root of 8 is equal to 2. My question is, cube root of 64, what is it equal to? 4. 4 times 4 is 16. 16 times 4 will give you the 64. Okay, so 4, 2, that gives 64. So I know now, I can break this apart. I can write this now again. If you didn't know that, if you had troubles working out what the cube root is, instead of writing it's negative 4, then you can now do it this way. And I want to show you, instead of knowing the answer, you can break it down. Write down the 64 using what you learned back in year 7 factor tree. Give me 2 factors that multiply to give you 64. You can do 8 times 8. And you can break that further. You can break the 8 further. You can say, all right, well, 8, I can break that down into 4 and 2. I can break the 8 again down to 4 and 2. Now what this suggests is you can break this in further. It becomes 2, 2, 2, and 2. Now this becomes a problem because you have 2 times 2 times 2 times 2 times 2 times 2 is equivalent to 64. How do I get all those 2's? Here we go. That's 1, 2, 3, 4, 5, 6. That's how I know 2 times 2 times 2 times 2 times 2 times 2 give me 64. Now, if you did do it this way, you can rewrite 2 times 2 times 2 times 2 as 2 to the power 6. So you can write that down and we can say, all right, well, that is the same thing as negative of 2 to the power of 6, power of a third. But you already know from your index laws that you can do negative 2 to the power of 6 times a third. The only thing you have to be careful about when you're multiplying this is when you're doing a third times a 6, you have to also make sure that the third is times into the negative 1 in front as well, because that's 2 terms there. Essentially, this is what you're doing. You're saying negative 1 times 2 to the power of 6, power of a third. This is the same thing as saying negative 1 to the power of a third multiplied to 2 to the power of 6 to the power of a third. Okay, I'm just using your index law. Have you forgotten this index law where a times b to the power of m is the same thing as a to the power of m, b to the power of m? Yeah? So that's why when I wrote negative 1 times 2 to the power of 6 m, this is the same thing as writing negative 1 to the power of m times 2 to the power of 6 to the power of m. That's all I've done. Okay, so I'm just using your index law. You do negative 1 to the power of third to 6 to the power of third. So you can multiply the powers using your fifth rule. And you know that negative 1 to the power of third, negative 1 to the power of anything is going to be itself. It's like 1 to the power of anything is going to be itself. Or another way of thinking about it is cube root of negative 1 is negative 1. So this now becomes negative 1. This is going to become 2 to the power of 6 times a third. And we know that's negative 1 times 2 to the power of 2. Negative 1 times 4. That's why the answer is negative 4. Okay? Now the skill here that you're taking out of 13b is revising all your index laws to do this. Because when you get numbers that you don't know, you can still break it down and solve. Now this one's a long way of doing it. For me, I personally would have tried to figure out a third means that something times itself will give you the answer. So when I break down the factors, I'll see, can I rearrange this to have just 3 numbers? And you can say 2 times 2 is 4, 2 times 2 again is 4, and 2 times 2 again is 4. This will make your problem much easier because instead, you could have wrote negative 4 to the power of 3 to the power of a third, and this is much easier. This is the same thing as saying negative 1 to the power of a third times 4 cubed times a third, and that now becomes negative 1 times 4 to the power of 1, negative 4. That's how I would have done it. Okay, so this is the approach I would have taken, but if you didn't know to choose those groups, if you didn't know to break it into 4, 4, and 4 to get 3 numbers, then you can still do it by this way, and that still works as well. Okay, but the technique that you want to use is factor tree. Okay, use factor tree. So if I try the next problem, 9 to the power of negative half. See, for me, I know to get 9, and I need 2 numbers that multiply, because that's currently 2. It's square root. I would do squared, 3 squared. So I'll rewrite this as 3 squared to the power of negative half. That's the same thing as writing 3 to the power of 2 times negative half. It becomes 3 to the power of negative 1, 1/3. Okay, so you see I'm following the index laws. I'm just saying 9, I can replace 9 as 3 squared. Why did I choose 3 squared? Because there's a 2 there. 2 times a half counts that to be 1. So it's the power of negative 1. 3 to the power of negative 1 using your second last rule becomes a third. So 13b allows you to work with factor theorem, factor tree, and you're breaking it down using your index laws. That's what they're trying to get you to do. Okay? Let's try the next one. Let's say 64. Actually, I'll do 16 to the power of 5 on 2. Same drill. 16 to the power of 5 on 2. Notice that there's a 2 here. So if it's a 2, you got to think of a number that multiplies itself to give you 16, which has to be? 4. No?
I'm very smart.
4. 4 to the power of 2 is the same thing as 16. Power of 5 on 2. That becomes 4 to the power of 2 times 5 on 2. And again, 2's cancel out, so now you're left with 4 to the power of 5. Which is a bit hard to work with. Okay? I don't know what it is. Yeah, 256.
1024.
Is it?
Yep.
Alright. I trust you. And I trust the cats. I guess another way of thinking about it, you could have done 2 squared. Nah, I don't think any other way. Alright. Last example, guys. Last example. And then that's 13b. Here we go. Let's choose out of A and B, which one do you think is harder? You tell me which one and we'll work through it together.
There's X and Y. A, because it's a fraction.
Start with what?
Oh, square roots are
A or B?
A, because it's a fraction and it has square roots.
Yeah. Alright, A then. A has a fraction and has square roots. Let's work with this one. So, the question says simplify, it doesn't say evaluate.
There we go.
Yeah. It says simplify, so your goal is to simplify. Now notice, the problem here is you've got base 3, base 3, base 6, base 2, base 16. The problem with index laws is you require the bases to be the same. If the bases are different, you can't simplify. So your goal right now is to group in bases that are the same. The only way to do that is if you separate it into its factor, like the smallest factors that you can have. So you see 3, I would leave it as 3 to the power of quarter times. Now 6 to the square root is the same thing as writing 6 to the power of half, which is 6 to the power of half, times now 2 to the power of fourth root. Fourth root, another way of writing that is 0 of a quarter. Yeah, 2 to the power of a quarter. Fourth root, a quarter. Cube root, a third. Square root, a half. Fifth root, a fifth. Sixth root, 1/6. Seventh root, what is that, Will?
1/7.
That's it.
I'm fan.
Over 16 to the power of 3/4. Now, what we can see is I've changed them all into powers, but the bases are still different. This is how you break this apart now. 3 to the power of a quarter times, now 6. You can break that into 3 and 2. So you can break it to 3 times 2 to the power of a half. That's still the same thing as 6 to the power of half. Times, this is still the smallest base, so I'll keep it as 2 to the power of a quarter. But 16, I can break that down to 2 to the power of 4. So I can write that down as 2 to the power of 4. Now this is looking nicer. Now I've got 2 bases are the same. 2, 2, and 2. Your job is to use the index laws and break it apart. So here we go. I'm going to break out. This is the part that I want you to focus on. Right here, you can break it apart using the rule I just showed you before. We had a, b to the power of m was the same thing as saying a to the power of m, b to the power of m. So that means you can break this bracket here. It becomes now 3 to the power of half times 2 to the power of half. This is 3 to the power of a quarter times that times 2 to the power of a quarter. This now becomes 2 and the 4's cancel out, so 2 cubed.
This is some sort of form for physics.
No, it isn't. I'm just showing. Now that you've broken it all apart, you can group them. You can say base 3's together, base 2's together. Okay, so if I do that together now, if I just go to the next step, you can see this now becomes 3 to the power of a quarter. When you times them, you add the powers, so a quarter plus a half, times, this is 2 to the power of half plus a quarter. And remember, because you're dividing, it stays over there and you can write that as 1 if you want. So I'm just separating them apart. Okay, so this now becomes what? 3 to the power of... That's 3/4. Half plus a quarter makes it 3/4. Times, now that's 3/4 take away 3. Yeah, another way of thinking about it is 2 to the power of half plus a quarter take away 3 because you're dividing. This now gives you 3 to the power of 3/4 times 2 to the power of 3/4 take away 3, which is 4 take... Yep. Times 2 negative 9 on 4. So you leave your answer as 3 3/4 times 1 over 2 to the power of 9 on 4. And that makes it now 3 3/4 to 9 on 4. Okay, I'm just going to zoom out. So the key step here isn't the fractions. Wasn't the fractions part. It was this key part here. Without that, you would have been stuck here. The only way to go further down was to break 6 into 3 times 2 and then break it apart. That was the key step. Okay, so 13b, that's what you take out of 13b, is that step recognizing what you need to do there. Other than that, everything else is the same. Index laws, 13b is just focusing on using your index laws a bit more instead of creatively. Okay? Anyways, you've got about, that's about 10 minutes. You guys can revise chapter 7. Kaz, any questions you want, you can ask me. But once the bell goes, we're starting our SAC. Okay? Yes. I don't even know, actually. I haven't solved it.